Okay, and then share my screen. Okay. So I'm gonna kind of go over a couple of these things again, because I'm gonna add some more to it than what he went over, and I've got a couple demos that'll help kind of hopefully make this make a little bit more sense. Okay. So keep in mind that hubs, or you cannot buy hubs anymore. They're not for sale anywhere. You can buy them on eBay maybe, but nobody's deploying new hubs. The chances of you finding one in the wild, it depends on where you work. If you work in manufacturing or certain industries, you'll see them. We're not buying or deploying new hubs, and in every opportunity, we're replacing them if we can, because they just cause nothing but problems in our networks. There's no reason to have them today. The cost of switches is relatively low. When we're talking about switches, when we spec switches out and stuff, we talk about cost per port. Well, a 100 meg port is like 10 bucks, 15 bucks a port, okay? Gig is maybe 30. 10 gig is maybe 100, 200. 40 gig is probably about 5,000 a port. 100 gig is currently about $10,000 a port. So that's kind of expensive. Okay. To give you an idea, when 40 gig first came out, it was $225,000 for 2 ports. Okay. Within 2 years, that was down to 10 or 15,000 a port. Okay. So the prices changed quite a bit. Now, where we're using those kinds of switches, where are we using these big boys? These are in big companies. Like this is a modular switch. This is an HP ProCurve. It's a really popular brand. They're the 3rd largest switching manufacturer in the world. They're very competitive with Cisco. And they make really good switches, but something like this, you're looking at a modular switch here that's $30,000. Okay, switches range up into the $500,000, $750,000 range for high-end data center switches. Okay, a carrier router, to give an example in cost, can be $1 million plus for some of this equipment. The equipment we focus on and work with is basically under $10,000. Okay, most of the stuff that we're really focusing is on small to medium business, LANs, not WAN, so we're not really worried about the carrier stuff. So we're really only dealing with stuff in the probably sub $15,000 range. Most of the routers, like a branch office with 30 to 50 people, that router's only $1,000 to $2,000. Okay. The switches, we spend more money on switches than we do on routers in the LAN. The carriers spend all their money on routers and very little on switches. Okay, because they don't do a lot of Ethernet unless they're running MPLS and stuff. So we have this thing called the CAM table. The CAM table is just specialized memory. It used to be specialized memory. Now we just run it all in RAM. So it's a terminology thing. Do you see it in the CAM table? That's me saying, do you see it in the MAC address table? CAM table and MAC address table are interchangeable in our terminology. CAM is the very specific term. Yeah, I know. Okay. So when we're looking about managed versus unmanaged, okay, in enterprise, we do not buy unmanaged equipment. We don't buy unmanaged gear. An unmanaged switch doesn't do VLANs. It's unconfigurable, okay? So an unmanaged switch is very similar to a hub, but it is a switch with a MAC address table, okay? Meaning that there's no real, beyond the protocols and stuff associated to MAC, that's all it handles, meaning no spanning tree. So there's no loop protection on unmanaged switches. They rarely have spanning tree. Spanning tree requires configuration. Okay, so they're not going to have that. So when you buy that $150 Netgear or $100 or $80 home switch that's unmanaged, you plug devices in and it works. That's all it'll do. Okay, no VLANs, you can't manage it. There's no security, nothing. Okay, we don't ever use that kind of stuff in enterprise. We haven't used the unmanaged switches in enterprise for quite some time. Okay, everything we use are smart switches or better. Smart switches are kind of that go-between. A smart switch is a cross between a managed and unmanaged. It has a web interface and has some advanced features, but it doesn't have all the features that a fully managed enterprise switch would have. Fully managed switches are typically not in a GUI. They're typically all command line. In networking, routing and switching is command line. Security is a cross between command line and GUI, okay? But we do a lot of command line in networking. Okay? We do it a lot in server administration today too, because everything is scripted. We use PowerShell for all our automation in Microsoft. We use Bash Shell or Python or something similar in Linux environments for all of our automation. Okay? Anytime we want to do something repetitively. Think about doing something repetitively in a GUI. How do you add 50 users in Microsoft? My God, that would be terrible. Or I can just write a script and it's done like that. I have it read out of an Excel spreadsheet. And I just run a script and do all that. So that's why we have all those things, to do that automation. Because doing things repetitive in a GUI is horrific. So think about trying to add a bunch of users to a firewall or something like that. If you had to do that in a GUI, it would be very slow and cumbersome. So even most of the devices, many of the devices, security devices that are GUI driven, they have command line for them. So you can do both. Okay, so that's where let's take a look at specifically, let's take a look at some switches here. So what I've got is, whoops, that's not what I want. Okay, why is it not? There we go. Cisco packet tracer, and we are going to look at, I think this one. This is packet tracer. What this allows me to do, well, that's one of them. I think it was VLANs is actually what I wanted to look at. Okay, here we go. This is it. So this one allows us to show a couple of the different things that you guys have already talked about. So in switches, in switching environments, we need redundancy, okay? What if a switch goes down or a cable gets damaged or something? The problem is to form redundancy means we have additional links that connect everything together. That redundancy creates a switching loop. The switching loops create uncontrolled broadcast storms and will wipe out our switches. Usually when I do a demonstration of breaking a switch, causing it to basically shut down and be unusable, and what we do is we turn off spanning tree and we create a broadcast storm, and basically within a second it goes from no traffic to 100% traffic on all ports and crashes. Okay? Without spanning tree, we cannot get rid of our switching loops. And so what we need is we have to have the loops there for redundancy. So I have to have this loop here, okay? Otherwise, if one link breaks, I have hosts that can't communicate. So what I can do is I can make one port go into blocking. This port, when an outage happens, another port is going to go, this one is going to go active and the other port will go down. So if I break this link, let's say I delete the link, so gig02 to gig02, what we're going to see happen Hey, we're back in business. We're back in business. Sorry if I lost you. If you're listening to the recording, the batteries ran out, and I ran down the hall. Okay. So Wireshark is how you're going to want to use things like this to be able to see traffic and to kind of visualize what you're seeing on the slides, okay? Use Wireshark. Wireshark at home, it's not going to hurt anything. It's not a security issue. Don't let people tell you it is. They don't know what they're talking about. Yeah, just go to Google and search for Wireshark. It's free, okay? Windows app, Windows, Linux, okay? There's a Linux version that works really well. This is ancient. This software is 20 years old. Okay, I've been using it when it was known as Ethereal back in the 90s. Okay, I've used this since Windows 95. To give you an idea. This is how I was doing packet sniffing back in Windows 95 days when I worked doing tech support on a hub network. TCP/IP is TCP/IP. It's been TCP/IP since the 90s, since the 80s. The equipment has changed. It's gotten faster. But IP version 4 hasn't changed at all in 25, 30 years. Okay? IPv6 is what's changed. IPv6 is what's new. But you have to realize this was all developed in the 60s, 70s. Boolean logic, the way computers work, came about before we ever had a circuit or computers or anything like that. Alan Turing came up with it in the 20s. Okay? When electricity was still not super commonplace everywhere. Okay, let alone computers. The logic that we use in computers was developed way before computers actually existed. Then we just figured out how to make vacuum tubes, count zeros and ones. And they would take up huge rooms. And then we developed the first transistor. And that's where we are today, is now they're really tiny. And we stack them, make them 3D, make them out of all kinds of exotic crap. But that's basically, we just miniaturized something that we developed in the 50s and 60s when we developed the first transistor. And stuff. In the 50s and 60s, the mainframes that we had of that day were vacuum tubed. You think it's big? You think a mainframe is big today? You have, wow, like whole buildings to do what, not even as fast as what my phone is today. Okay? Multiple floors on a building. That's how we got to the moon. You know, was these machines that, you know, anybody who watched the movie about Alan Turing? There's a movie that just came out like in the last year or two with Alan Turing. He was part of that. Alan Turing he's the father of computing. He's considered the father of modern computing. Okay. Yeah, it's a Turing test is used to for AI, for artificial intelligence. Yeah. And they got some. So Cisco Network Academy, to get support, it's now a bot. You can't actually get a live human. You have to work through this bot and get it to help you. It's all an AI bot. That's how a lot of support and stuff is being done now, is AI bots. You won't know. They're good at what they do. They're pretty good. Okay. There was a self-learning bot that I think it was Microsoft or Facebook or someone put out. And it was, within 2 days, it had become they had to take it offline because it became super racist and everything because of all the crap people told it. Like it was saying horrific stuff by the end of 2 days of all the stuff it had learned. And so they took it offline because it was like, yes, I think we should roast humans alive. You know, just like, oh my crap. It's like, let's take that thing offline before it gets any more power, okay, guys? All right, so because a switch does not broadcast traffic out usually, as soon as we populate the MAC address table, it's only forwarded to the port that it's supposed to go to, okay? So we can't sniff. We can't just sniff traffic. We have to mirror the traffic to get it to us if we want to do that. And so remote mirroring tools, we can do what's called RSPAN, but we usually use that for testing, debugging, network monitoring, and especially IDS, intrusion detection. Okay? Intrusion detection will find malware and stuff before it gets to a computer. It'll see it in the packets as it goes by. Okay, and it'll notify a firewall to block it. So, different VLANs, different broadcast domains. We already kind of covered this. Usually, we're using static port-based VLANs, meaning if you plug into this port, you're on a certain VLAN. In high security environments, we can tie your VLAN to your login. So we can use a system where basically your computer gets nothing until you authenticate. And then as part of the authentication process, we use a AAA server that goes, oh, this user belongs to VLAN 20. And it's a dynamic assignment. So theoretically, you can plug your computer into any switch and you'll be on the VLAN you're supposed to be on because it assigns that through a AAA server. Yes? Kerberos is the Windows authentication system. It can potentially use Kerberos, okay? Usually we're using what's called EAP, Extensible Authentication Protocol, and it's using what is called 802.1x. We'll get to that, okay? That's in Module 5. At the end of this, like the last day, we'll cover 802.1x or the day before. Okay, we'll cover a little bit, but it's all about network access control. Who can get to the stuff, and when we can tie that all through AAA and do dynamic assignments, dynamic VLANs, dynamic security, okay? So the traffic between VLANs must be routed. In most businesses, we route the traffic between VLANs with layer 3 switches because they're faster, much, much faster than routers. The routers stay at the edge and route our traffic between our LAN and our internet connection, okay, our WAN. The reason for it is routers have special things that they can do and they have specialized interfaces that switches don't. Switches can tend to do certain things much faster than a router because of their hardware. But there's some things that they can't do because they have a very weak CPU. So the CPU is very low power on the switches. All the guts are those ASICs, the application-specific integrated circuits, are where all our power is coming from and our processing and stuff on those switches. We have a CPU that runs the operating system, okay? So it can handle some of the tables and stuff that have to go into RAM and command line and all of those things. But you have to realize the operating system is 20 megs in size, 30 megs in size. The switch runs on 64 megs of RAM. 128 megs of RAM, maybe 256. A router may run on as much as a gig or 2 gigs or 3 gigs, right? But routers commonly only have 512 megs of RAM or a gig. They don't have bloated operating systems called Windows and Linux, right? They don't need the memory. Now, a Linux-based router would need more memory because it's running the Linux kernel and it requires more memory, right? I'd want probably 2 gigs if I was running a Linux-based router. You can have a Windows-based router. You can do Windows-based routing. I don't know why the hell you would. Like if you would like the most bloated, crash, least performing router, you can use routing and remote access services, RRAS, on a Windows server. It's just it only supports RIP. I mean, they know nobody actually does this, but it does allow for it, right? Yeah, no, Microsoft uses tons of Linux stuff. Like half of Azure is based on a Linux, not Windows machines. Yeah, they do a lot more with Linux now than they used to. They've had to. Linux is 50% of the server market. They can't just, ignore what Linux does. Most of the web servers in existence today are Linux, not Windows. Why? It's free. Why would I pay for my web server? I need Active Directory. So in the LAN, Microsoft servers rule because they manage Windows clients better than anything else does. In the server farm world, once we get into web servers, database servers, those kinds of things, Linux rules the world, okay? The thing that run most websites are not running Microsoft and Microsoft SQL as their back end. There are ones that are out there. But that's not the dominant out there. It's Apache, it's Nginx, it's PHP, MySQL, NoSQL. Okay, these are all stuff that we run for free on Linux. So why would I pay $600 for a copy of Windows Server when I can pay nothing? and have something that's just as secure, runs with less resources. Okay? There's a reason why. Linux is awesome for certain things. I would not use Linux to administrate Windows machines. I would not use Linux as a file server. Okay? I'd be using Windows for those things because that's what Windows does very well. Everything has its pros and cons. Cisco's really good for some stuff. There are some things I would not buy as far as Windows products go. I would not buy any of their small business products. Wouldn't touch them. Okay? They're not actually made by Cisco. They used to be made by Linksys. Okay? I would only buy their enterprise gear, not their small business stuff. There's some of their small business stuff just isn't very good. Cisco bought Linksys. They owned Linksys, okay, to make their gear, to get into the consumer market, and then they went, oh, this is a bad idea. And they sold Linksys off. And they got out of the consumer market. Cisco doesn't make consumer stuff. But they do make some Soho stuff, and I would go with the other brands. You're paying a lot of money for not great features. Their higher end stuff is amazing, is the best there is. But that's enterprise, and you got to have the money for enterprise. Your small mom and pop can't afford Cisco. They just can't. It's so much money. Yeah. No. Apple doesn't exist in the enterprise realm. Apple is not present in enterprise. Okay? So Apple doesn't make servers. They don't make any networking products that aren't consumer-based. They only make consumer PCs, consumer tablets, and consumer phones. They do not make anything enterprise. So, do we have Apple in enterprise? Yeah. It sucks. It absolutely sucks as an admin to manage Apple products. So, when you work for an arts company, work for a marketing firm, stuff like that, you're going to have MacBooks. Okay? They use TCP/IP. But they don't support all the Windows file sharing. There's some issues. And they don't support things like group policy and all the things that Active Directory allows us to control. Okay? And they don't make a server that does that. Apple has made servers in the past. They don't make them anymore. And their servers were crap and super expensive for what they were before. I know at CWI I had 2 servers that were worth $24,000 or $12,000 each. And what did we use them for? Collect dust. Because they can't run anything. They can't run any of the stuff that we actually use in servers for the most part. Because again, Apple doesn't make that software. They don't make server software. They don't make server applications. Okay? So while we do have some stuff to work with Apple machines, it's very difficult for us to manage iPhones, iPads, and those kinds of equipment. Now, the mobile stuff is easier than the PCs, the machines themselves usually, okay? Because we're forced to do bring your own device in companies today. And so we have servers. Microsoft has a bring your own device kind of management server for mobile devices. And there are other companies that have products like that, Cisco as well, that has products for managing things that are agnostic, okay? So they're not specifically to iPhone or Android. They basically support any kind of mobile device that's of a major operating system. And they have apps and stuff that you use, like the VPN app you can get that on your iPhone, stuff like that. But Apple doesn't play in enterprise. They do not appease businesses. They do not make business class equipment. When you buy a Dell business class machine, it actually has some features in it for management that normal home computers do not have. Okay? Macs never come with that. Okay? So there's certain things that we do in business machines that allow us to encrypt them remotely. So like they may support TPM. TPM modules allow us to secure, especially with laptops. You won't find a MacBook that supports TPM most likely. Chances are they don't support that. I would have to look. I don't know. I've never owned a MacBook. But they're not going to support the enterprise level features because Apple doesn't make money in enterprise. It's always been that way. Apple early on did something that got them a lot of recognition and got them a lot of presence in the late 80s and early 90s. And that was give all the schools Macs. okay? And so if you are someone of my age, you grew up with Macs. That's what it was, because that's what all the schools had. When I was in high school, they started getting rid of all the Macs and replacing them all with DOS machines and basically DOS machines, right? This is like Windows 3.1 days, okay? And that's when it started, and it continued. Education, you'll see a lot of, in big university, you'll see a lot of Mac users, right? In networking, it's rare because virtually none of our stuff will run on a Mac. Usually what I have, when a student comes to me and says they have a Mac, the first thing I tell them to do is to get VMware Fusion and run Windows in a VM on their Mac so they can actually do the work necessary for the courses. Packet Tracer works on Linux, not a Mac. Okay? You're better off running Linux than you are running a Mac in our realm. Okay? Same in enterprise. Linux is built for enterprise, not built for consumers. Oh my God, not built for consumers. It's built strictly for enterprise, and that's what you should use it for. Using it as a consumer desktop is just frustration, right? Some people do, but there's a reason why Windows is 90% of the market. The desktop market is 90%, okay? Has been for a couple decades now. It has not changed. What does Linux have? 1% to 2% at any given time, a desktop. Mac has the rest, okay? You know, they're usually 5 to 7% of the world's desktops are Mac. But phones are, they're about 25 to 30% of phones. Samsung is the biggest. Android is like 60% of phones on the market are Android. Samsung being the biggest chunk of those. And then Apple being a singular, you remember only Apple makes the iPhone, where tons of manufacturers make Android. Why do you think Android holds 60, 70%, right? 60%, right? Why does Windows hold 90? Who makes Windows computers? Dell, HP, everyone. Who makes Apple computers? Apple. It's all about marketing and business decisions, not necessarily what. Early on, Mac was better. Straight up, it was better. But they chose to not open it up. Bill Gates was smart. IBM was smart. Okay? Let's build the IBM PC and let other people make hardware. Let's open it up to competition, innovation. Boom! Take over the market almost overnight. By the late 80s, Apple was seriously getting hurt. And by 90, they fired Steve Jobs. And during that time, Apple really, really suffered during the early 90s and stuff. And then when they brought him back after he sunk Next, which was the other company he was running, shortly thereafter, the first iPhone hit the market. Right? Like 2000, whatever, when the first iPhone. And now, 10 years later, people couldn't dream of not having a smartphone. But they just don't dominate enterprise. They just don't play there. And there's plenty of companies that only play in the consumer realm. Why? Businesses have lawyers and can afford to sue. That's one of the reasons, okay? As a business, I don't want to work with other businesses. Dealing with consumers, while it's kind of a pain, it's much easier to basically make huge profits off of consumers. Consumers are very easily manipulated through marketing. Businesses are much more difficult to manipulate through marketing. Okay? Consumers are easy to just throw ads at and trick them into buying anything. We do it all the time. I mean, come on, fidget spinners. So, on a side note, I saw something this morning that was absolutely hilarious about fidget spinners. And it was some memes, right? And someone was posting, and they were like, what you see in the emergency room, and it's a picture of one of the screens of patients, right? And one of them is a 9-year-old with fidget spinner stuck on penis. Wow. So why do we do the VLANs? The VLANs provide security. They shrink broadcast domains. Broadcast domains used to be a really big problem. Modern equipment, it's not so much. So we want to shrink them. We want to create security boundaries. We put our firewalls, our IPSs, our security between the VLANs. Okay, so that we create that separation. And that separation fits with the business model that we're using for the company. So we just don't go, hey, we're just going to separate it any way we want. We look at the structure of the company and the job roles. As an administrator, you have to learn everybody's job in the company. You should. How are you going to support them? How are you going to know how to make their job easier if you don't know what their job is? Our role is not just to fix problems. That's when you work for a company that doesn't have good funding and doesn't embrace what IT can bring for them. I can make people's jobs easier. I can make them more efficient. I can create unique solutions for the company that make them money, make a larger profit, if they give me the time and hire the right people to be able to do that. That's what we should be doing. And there's plenty of companies out there that see that that's the role we play. There's plenty of companies where I've done 75 tickets today. Yay. Okay? There's plenty of that too. So 802.1q is the tagging mechanism we use for trunking so that we can move multiple VLANs between two switches or multiple switches. Okay? Otherwise, we'd have to have an access port between the two switches for every single VLAN. Well, some switches will have 50, 100, 200 VLANs. It doesn't have that many ports. There are switches that have 700 ports, but those are a little bit of money. Yes. 802.1q is specific to VLAN trunking and VLAN tagging. The name of the tag is an 802.1q tag. Okay? And this is the tag. We insert the tag. That's like when we talk about the MTU. The MTU, the maximum transmit unit for Ethernet is 1518 bytes. Or 1522 when you have VLANs. Is the VLAN tag. Okay. Okay, so untagged traffic, I talked about this before, it goes on the native VLAN. That is typically control traffic, stuff that didn't come from a data VLAN, that didn't come from an access port. It's when the switches talk to each other. Okay? All of this networking equipment talks. Your PC is constantly chattering to all the other PCs in the room and to the machines and stuff. There's all these protocols that are being broadcasted. ARP. We have ARP, we have spanning tree, we have LLM&R, we have DNS, we have DHCP, we have all this stuff going back and forth between all our things. Well, some of those are from the actual routers and switches themselves and are control traffic. Those things need to go in the native VLAN and remain untagged. So that's what the native VLAN allows us to do. Is when we see something that's untagged, we just assume it belongs to whatever native VLAN is configured on that trunk link. And one of the problems we have with trunks is you have to use the native VLAN on each side. Okay? So you'll get a native VLAN mismatch, meaning, hey, I put 99 over here and this one's still set to 1. Well, I got to set that to 99 and the error goes away. And your trunk will function once you have that. You have a question? Okay. Okay, so default VLAN, already covered. Native VLAN, I've covered. Propagating VLANs. So we have a protocol called the VLAN Trunking Protocol, VTP. VTP is Cisco proprietary. Why they're covering Cisco proprietary crap in this, I don't know, but I've seen a bunch of it already with the other person I've been teaching on this stuff. Well, in the fact I've taught it before. So VLAN, the VLAN Trunking Protocol, just make sure all the switches in kind of one area of the network that are sharing VLANs, why wouldn't I just configure all the VLANs on one switch and have that switch tell the other switches about the VLANs and their names? Then I have consistent numbers and names, okay? Welcome to the VLAN Trunking Protocol. That's what it does. So there's a VTP server, that's where I configure the VLANs, and I configure the other switches as VTP clients, and it feeds those VLANs to the VTP clients. And then I assign the ports that belong to the different VLANs, okay? So I still have to do that port assignment. Switch port mode access, switch port access VLAN, and the number that's associated to that port, okay? But the big benefit to VTP, why we like to use it is consistent VLANs and consistent VLAN names, okay? So it's easy, it lowers the administrative overhead. but it does VTP pruning. The pruning is awesome. So that's the one thing VTP is dangerous. Okay, you can wipe out your network if you don't know what you're doing with this protocol. Okay, but when used properly, and you have VTP pruning enabled, and you have a dynamic network where you have people connecting and disconnecting often, then this will save you bandwidth on your trunk. So what it does is on a trunk link, we have a list of what VLANs can go across the trunk, okay? Normally, we allow all the VLANs to go across the trunk. But with VTP, we can turn off VLANs that aren't needed. So I have a switch, and while it has VLAN 10, no one is currently turned on VLAN 10. Meaning there's nobody who has a computer that's actually powered on that's plugged into a port associated with VLAN 10. So why would I trunk VLAN 10 to that switch? There's no VLAN 10 traffic, either beginning or ending with that switch because there's no one on VLAN 10 on that switch. So VTP can detect that and prune the link. And the moment someone plugs in and that port goes live, VTP changes the allowed list of VLANs and allows that to flow. We preserve bandwidth on the trunks. That's pruning. We're pruning the VLANs off the trunks of VLANs that do not need to go over the trunk because their destination switch isn't using that VLAN at this time. Okay? Otherwise, we have to do that manually with commands. So we can do auto pruning with VTP. If you're not using VTP, pruning must be done manually with an allowed list. So you say allowed VLANs and you list which VLANs are allowed across the trunk. Okay? Usually switches will have two trunks. So one access switch has two trunks to two other switches. So if one trunk goes down, it will be able to still communicate. So we have some redundancy. And we're doing usually load balancing or we've got spanning tree, whatever, okay? So this is kind of where he left off yesterday. I wanted to kind of clarify some of the stuff and go over some of the stuff in Packet Tracer to hopefully clarify this. So spanning tree, when we have the loop, spanning tree detects the loop because it sees the BPDUs go around. So first, what happens is we do what's called the root election. So the switches boot up, and whoever has the lowest MAC address out of all the switches have a MAC address associated to them for their management. Whoever has the lowest MAC address of all the switches gets to become root, okay? And root is how we decide which ports go blocking, which ones go forwarding in spanning tree, how we break the loop and how we reestablish it, okay? So that root is what we call as a bridge ID. It's a priority number and a MAC address. By default, all the priorities are the same, so it goes by the MAC address. However, if I go in and I lower my priority, I can throw the election, and I can force a particular switch to be root. So what we do with this is I have my root that's connected to my router, and I have two switches, okay? And these are interconnected. So this is our triangle that we demonstrate this stuff with, okay? But I have multiple VLANs, okay? So in spanning tree, just basic spanning tree, there's only one tree for all VLANs, meaning there's one map for all the VLANs, and one link is going to go into blocking, and we can't use that link. Okay, then we have what's called rapid spanning tree. Just does everything faster. So there's less lag involved. Okay, a little bit more overhead though, because it keeps track of ports. But basically it's just doing everything faster. Then we have what we call per VLAN spanning tree or multi-spanning tree. What that means is different VLANs have different trees. This is how you can utilize all the links. So what we do is I throw the election, so I make this root for VLAN 1. And I make this root for VLAN 2. Okay? So for VLAN 1, I'll use brown here. So for VLAN 1, based on path cost, and the path cost is the speed of the links. So this link may be gigabit, this may be 100 megabits, so they have a path cost, and that path cost is to get to the root. Okay? So we need to determine of this switch, which one's going to have the worst priority, going to lose all the elections. That support we're going to shut down. That support we're going to block. So let's say we have a path cost of 8, and we have a path cost of 10, and we have a path cost of 4. Okay? So for this switch to reach the root, it has a path cost of 8 or a path cost of 14. Okay? So this port is going to go in forwarding. It's going to send traffic. That's the shortest distance to the root. It's got the lowest path cost. Okay? And then what's going to happen is we're going to have a kind of a competition. Is it this link here that we're going to block? Is it this link here or this link here? Okay, so first we have to make a decision for this switch. Well, look at its path cost. It can get to the root for VLAN 1 with a path cost of 4 or 18. So this port is going to go forwarding. Okay, so that port there is going to go into forwarding. And these are what we call, they actually get a special designation and they're called root ports. The reason they're called root ports, they're the closest port to the root. Okay? So a root port is a port that's in forwarding, and it is the lowest path cost to the root bridge. The root bridge is the switch that wins the election by either having the lowest priority or, when all priorities are the same, having the lowest MAC address. And the combination of that is called the bridge ID. That's how we identify these. So this election process happens. Okay, now we need to determine what port is going to go. Well, let's say this has a MAC address of AAA. This has a MAC address of BBB. And this one has CCC. The highest MAC address loses. So this port goes into blocking, and this one is in forwarding. Why don't we put both into blocking? You have somebody? Oh, he's here. Yep. So if you take both ports down, we take the whole link, so if we take both ports down, it's not going to come up as faster. It takes longer to bring 2 ports up, right? So this is forwarding, but any traffic coming out here is just going to get dropped by this port. Now, BPDUs, the bridge protocol data units that we saw in Spanning Tree bouncing around, are still traveling, but data can't go in and out of that interface. Okay, so it breaks the loop. So the problem is now I'm not using this link's bandwidth. So what I do, VLAN 1, the loop is broken here. But I set a different route for VLAN 2. Now for VLAN 2, different ports are in blocking. And then now, so this, maybe in this one for VLAN 2, maybe it's this one that is in blocking for VLAN 2, but it's in forwarding for VLAN 1. Now I'm using all 3 cables. And so what happens, if one cable fails, it all fails over to the remaining cables, and I don't have an outage, I just have less bandwidth. So it allows, I don't want to have a bunch of extra cables I'm not using. That's really not what I want. This allows me, per VLAN spanning tree, allows me to make different trees for different VLANs so I can balance them. And if I have 2 redundant paths, I basically make 2 trees. One that goes one path, one that goes the other. If I have 3 redundant paths, I would make 3 trees. Okay. So 802.1d is the standard that we use for spanning tree. There are many standards. There are Cisco proprietary standards. Specifically, spanning tree, so STP, RSTP, and MSTP are all open protocols that everybody supports. PVST and Rapid PVST are Cisco only. Why don't we go ahead and take a break? We did kind of stop back there, but let's actually take a break. Okay. Sorry, just we've been going for a long time. So. I thought they did. Did you guys do the pretest Tuesday? Oh, no, we haven't done the pretest, and a bunch of people are missing. I actually, you guys did. I gave it to him and explained him how to do it. That's fine. We'll probably do it tomorrow and see if more people are here, and we'll do it then. Okay, I'm not. Well, so no, we haven't done it yet. I need to. Barb's going to get on me about that, so I got to get that done. We'll do it tomorrow. I'm not going to worry about it tonight. We got like at least two other people missing, I think. So. Mm-hmm. Don't. No, no, I don't. Because some of this stuff will actually help you take your A plus test. Yeah, so some of the networking questions in A plus, some of the troubleshooting, some of the things that we will run across will actually assist in just the understanding of computers and networking and how things work. Okay. Okay. Yeah, so that like definitely the networking stuff that's in there, you should be pretty strong on that when we get done with this. I would now don't stop practicing the exams and stuff. Don't just ignore A plus. What I would do is I would start practicing for the test and everything, but you should focus on this and spare time that you have, continue your A plus stuff. If during this part, if as you go through this, you feel comfortable to take, because there's two tests with A plus, you feel comfortable to take that first one, don't hesitate, take it, right? The longer you wait after completing a course before you take the exam, the higher the chance you won't ever pass, or you'll never take it. That's what happens. So usually if you wait more than a month, in my experience, if you wait more than a month, the chances of your failure skyrocket, okay? So, but it's all about the individual. The people that usually do that, just they went to school all year, they finished school, and then it's summer, and so they just brain dump, and it screws them. You can't just stop doing the A plus stuff, or you'll forget most of it. Okay, you need to keep going through test banks, stuff like that, and some of that will relate to this and reinforce those areas and make it a lot, especially the big networking stuff for that. We'll cover that in way more detail for this. Okay. Mm-hmm. You'll have to talk to Barb. I don't know. Everybody's different. Okay, so it's based on what, like, I had one lady that just got told today that she has to take it tomorrow, and we're still covering material. Okay, but she's in a particular program, and they told her that that's what they had to do. That's not our choice at LeapFox. So a lot of it has to do with how you're funded. So if you're a TIAA or a veteran, or I mean, there's like 20 different programs that people get funded through to come here. I mean, some people pay for themselves, and yeah, if you come in and pay, then there really is no restriction. Okay. But all those different programs they'll say, oh, you got to take it within 2 weeks, or you got to take it immediately, or so ask Barb. She will know who to talk to, who's the head of whatever that program that you're a member of. Okay. She handles all that stuff, so I don't have to, because I don't know anything about any of those programs. Usually, I just get sent paperwork and stuff I have to sign for veterans, and like I just had one of my other classes that I teach online. He just sent me something from that he's a veteran, and they have to have like a progress report halfway through that goes to someone. So he sent me that, and I had to fill it out. That kind of stuff happens all the time. But here, when you have paperwork like that, usually it's Barb or someone else that will help you with that. I'm only usually am involved if I need to write a letter for some reason, which I have on behalf of students. Like a student wants to take a particular course, we have to show that a course is actually going to affect what they're doing and that's appropriate and stuff. So sometimes I'll write a letter for that kind of stuff. But usually Barb will deals with all that. So she knows how all the programs and stuff work. Veterans Administration. And some people are here under worker retraining. Worker retraining has totally different requirements in veteran than if you're using VA benefits. And maybe if you're disabled VA, it's different than if you're using other kinds of VA benefit. Like the government has 20 different programs that they use for veterans for all kinds of different things. If you're injured and it's such and such, well, it's this program. Well, if you're, if you're worker retraining, it's this program. So it affects how they pay for everything. Yeah, so there's always new questions going into the exam, but the objectives for the exams never change. So when a new version of the exam comes out, objectives change. So we just came out with a new version of Security Plus. So there's the 04 and the 05 are now available. So the 04 you can still take until like December. And I think that's it. And the 05 just came available like last week or two. So new material will come out for that, and then we'll start teaching that version, okay? And that version will have different objectives. So it could potentially have totally different questions, okay? Network Plus hasn't changed in a while, but I don't think there's a new one on the horizon right away, okay? We're probably maybe 6 months to a year before a new one. I haven't seen a new one talked about at all. Security Plus, they don't do all of them at the same time. They kind of do them in stages because they basically have one team of people work on the new version, and when that one's done, they work on the next one. But during the time, like the 3 to 4 years in between, Cisco is usually 4 to 5, not always. It's usually, anywhere between 3 and 5 years is how often they redo the certifications and come out with a new version and with updated information and all that stuff. But in between that time, the question bank that they use is always changing. So they take questions out, they put new questions in, questions that are, they're like initially when I took the CCNA security like a couple weeks after it came out, and everybody who was taking it were getting essentially the same 40, 50 questions because their test bank only had like 80 to 100 questions. Well, 6 months to a year later, it had 350 questions and the test was way harder. It was actually easier to take when I took it. And so that sometimes that happens, but usually not. Usually you'll just see some questions get rotated out and new questions get rotated in. Usually the difficulty level doesn't change. It does when you're encountering a brand new certification that they didn't have before. So like you're just talking, different versions of A+ are going to be built off of previous versions of A+. CCNA Security, when I first took it, was brand new. They didn't have books or anything. I got a PDF printout of what was maybe going to be the book and basically did it on my own and everything. And in that case, I got a fresh test bank that had never been used. There wasn't a previous version of CCNA Security. So in those instances, it can be kind of a ball game of, okay, did I take it a year after they came out with this brand new cert, or did I take it a week after? Chances are you're going to have a much smaller test bank and maybe have questions in it that are wrong or broken, or you could actually run into some issues early on, and they get all that stuff worked out pretty quickly. Yeah. It takes like 50 megs. It's just, yes. It could be the format that you have. It could be what format you're using. Do you have encryption software that you use with this at all?
It might be.
Because it's saying there's 3 gigs that there's gigs used and there's nothing on here.
I know, and then that's a 32 gig stick.
But why does it only say there's 6 gigs?
Oh, no, it's just mags.
I don't know that I can fix this. I don't know what's. You may want to get a different thumb drive. I don't know because that's really weird. Because yeah, 6 megs is enough. I need 50 megs of space. That's a 32 gig. That is really not reporting as 32. So let's take a look at this thing. So it's the 32 gigs are okay. I can fix it. I can fix it. Yeah, it's there is seriously messed up here. Why can't I delete that? exFAT. Okay. Okay, but why can't I delete? What brand is this? It's a SanDisk, right? I should be able to delete this partition, delete the volume, and then rebuild the volumes. There is something damaged with this, or this is a knockoff. Okay? Where'd you get it? Have you? My guess is it's been damaged or something. Something has happened to it. If you've used it previously and had it for a while, because it's actually not allowing me to delete the partition to rebuild this, or I could make it work. Okay, it's not even giving me the option, which I should have on this computer. I don't know. Maybe they locked my authority. I don't know. All right, let's try this one. What are you doing to your thumb drives, dude? That's the first time I've seen a thumb drive that had partitions like that set up on it. So hopefully this is a little bit better. Okay, hey, we're much better. There's no data on it. Oh, but it's actually an 8 gig and there's nothing on it. Okay, we're good. We're good. Okay, and then we're all good here. So, yeah, that's not good. Okay, so let's get this out of my way. Get in here. Yeah. A graphical user interface. Sorry. Just pictures, fun stuff instead of CLI, command line interface. Okay. No, by all means, ask. If I use a term you don't understand, pipe right up and ask, because I don't know what you guys don't know. I don't know that. I can't read your mind. You guys drink all the coffee? Yeah. Someone drinks it. I don't. There you go. Yeah, that other thumb drive. I don't know. That thing's magical. 6 meg partition. Oh yeah, his has got problems too. I don't know. Well, thumb drives are cheap, man. I have a really nice 64 gig. The college bought it, and I kind of took it when I left. It actually was just in my backpack. Didn't even realize. Okay. I don't know. Oh, I doubt the computer. I doubt any of the computers in here have USB 3. Nope. You don't have to. It's just I was putting the test bank and stuff on there, and the engine if you don't have it at home. So if you want that, bring your thumb drive over here, and I'll put it on there while we're doing this. We're waiting for people to return. No, we got. Well, in that case, I should have been doing stuff while you guys were all gone if we're only waiting for the important person. Hopefully your drive has not got voodoo or God knows what it's doing. Open sesame. Come on. I have a hard time with everything. Are you gonna pop up for me? kind of low on drive space. God damn, this computer sucks. In a year or two, that'll come up. Still not there. Okay. Yeah, that's not working. What? Oh, hey, finally. Yeah. Oh my God. Oh, you already have the tester. But what I'll do is I'll give you the test engine too. And I actually, my mouse just stopped working. Are you fucking... When in doubt, learn. I know. Oh, now it works. What the hell? Oh, man. This computer's fantastic. Oh, come on. This is why you should buy Dell. Every business you're going to run into has Dell. Sucks. I cannot stand their products. They're the biggest computer manufacturer out there, and they make some of the worst computers on the face of the planet. I'm very preferential to building your own. If I had to buy a machine, it'd be a Lenovo or an HP. My mom, I've bought her, well, she's bought several HPs that I've worked on for the last decade, and they've been pretty decent. Yeah, well, that's why I provide customer service. Right. So here's your thumb drive back. And it finally did that. Okay. Okay, so we kind of explained spanning tree quite a bit. Those protocol bridge units are what, the BPDUs are what the communication is. That's how we determine path cost. That's how we determine when an outage happens. And those things are sent out every 2 seconds. So there's a constant hum of spanning tree on the network. Now the thing is we oftentimes can disable or kind of get rid of spanning tree on our access ports if we want to do that, just so it's not spamming the end users. But a lot of times we don't want to do that, just in case someone does plug in a switch. Okay. And then we have the 802D, right? We have that one. That is originally spanning tree. Then we have rapid spanning tree, which basically just does everything faster. And so when we go, you see these disable, forwarding, listening, learning. Well, you don't have, I think we get rid of listening. I can't remember which one. Jesus, that thing is slow. Wow. So we have disabled, interface is turned off, okay? We have forwarding, means it works like normal, okay? We have learning, that's the listening and learning, you know how it's amber? And it stays amber? Well, it's like 15 seconds. It goes through listening. Then it goes through learning. Listening is figuring out who's the root, okay? We're listening to BPDUs flowing, but we're not allowing traffic. So we do that for a certain period of time, and then we transition to listening or learning. That's where we're populating the MAC table ahead of time so we don't flood the moment the port goes live. So that PC is already trying to send us DHCP and all kinds of requests out. So we're using that information to pre-populate the MAC address table. Then, after that transition period, we go into forwarding, okay? Now, if we detect there's a loop, we transition to the blocking, or what we call discard, okay? We can go to discard. That's spanning tree. Rapid spanning tree removes listening, or removes learning, and just does that, so it takes like 10 seconds and rapid spanning tree comes up. The other thing rapid spanning tree does is it marks an alternate port. That alternate port will immediately be transitioned into forwarding the moment an outage is detected. So where spanning tree has to wait and go through its whole process to bring up that backup, because it doesn't keep that track of that. Rapid spanning tree does, so that's why it's so responsive. Not only does it not have the same phases, so a normal port goes live in half the time with rapid spanning tree, it also has backup ports, so when an outage happens, the other port is put into forwarding immediately, so end users won't even notice that the outage happens. In the real world, we run rapid. We don't run just normal spanning tree. Overhead. Rapid spanning tree takes more resources on the switch. That used to be a problem with older switches. Older switches, we used to have a lot of problems. They don't have very much CPU power. Newer switches, we have plenty of power to run all these things, okay? Many, many, many of our constraints are based on historical problems that we do not have with modern technology. In the last 5 to 10 years, a lot of the problems that we had are gone. We don't have hubs anymore. Broadcasts, a machine can take an enormous amount of traffic. Back in Pentium days, broadcasts alone could slow a machine down by 10 to 15, 20%. That can't happen today. And when we first got gigabit Ethernet, it was possible to overwhelm a computer just trying to run at gigabit Ethernet. You could use all the resources to process that much performance. Now, a home computer can have a 10 gig interface and handle it with ease, okay? So some of this stuff that we talk about is literally 20 years ago were the constraints, and they simply don't exist in a modern network today. But you will run into stuff that's 20 years old, so you better know. That's the expectation. The simple fact is lots of companies use equipment that's very old, and if it does the job, why would you buy new equipment? From a home user, we like new, flashy things, right? We'll buy something new without it actually being worn out. Just because maybe we just wanted to burn some stress and spend some money. I'd do that. I'm an impulse buyer. Oh my God, between Cabela's and Amazon, I bought thousands of dollars of fishing gear I don't even use. I need a new reel. That's what I'm doing right now. I got to buy a new reel tomorrow. Out of the 20 reels I have, 10 of which sit in boxes I don't use, right? Okay, I'm an impulse buyer, right? So listening, learning, blocking, these are the states. VLAN aware, so spanning tree and rapid spanning tree are not VLAN aware. They treat all the VLANs equally. That means you can't do the load balancing thing. You can't have different root bridges. You have one root bridge controls everything, okay? So we usually use what is called multi-spanning tree, which is the open source kind of version that everybody uses, or we do PVST or rapid PVST. Those are only used on Cisco switches. They are not compatible with any other switch vendor. Okay, they're Cisco proprietary. There's a reason why Cisco controls 60% of the world's switching market. There are many, many Cisco-only shops. It means every piece of networking gear they have is Cisco. Learn everything. Everybody copies Cisco. Okay? The only major company, the only biggest player out there that doesn't copy Cisco as far as commands, structure, those kinds of things is Juniper. And I can teach pretty much anybody if you know how to program Cisco, I can teach you how to do Juniper in about 3 hours. It's all standardized protocols. It's just the commands. All commands can be looked up on Google. Shit, that's the easy part of our jobs. Commands are the easiest of everything that we do. Understanding the impact of the command is what we are paid for. Anybody can type in commands. I can write a script. I can make a program typing commands. I don't need a person for that crap. But understanding the impact that has, okay? You can hire, anybody can turn a wrench. Not everybody can turn a wrench and actually know what torque they're supposed to be at. What is that, what is that bolt actually doing? Okay, I can tell. I used to be a mechanic. I used to tear apart motors. My job was to pull the motor out, tear everything off of it, take the new motor, put all the old stuff onto the new motor, and then the mechanic came and made it run. All I did was remember where the bolts went and turn a wrench. I'm a mechanic. No, I have no idea what I'm doing. None. I knew that's a manifold. That's the exhaust one because it's ugly looking. The one that looks good, that's the intake. Right? And same thing. What we're being paid for is to know the impact of what is being done. When I type a command, I need to know how is that going to affect the functionality of the network. Knowing the commands isn't the big deal. It's knowing the theory behind what makes those commands do what they do. That's what we have to learn. A lot of this stuff, you don't master IP addressing, right? You suck at subnetting. Guess what? In the real world, we have calculators. We have tools. Doesn't matter, right? Now, I have run into a case where the tool was programmed wrong, and one of my students found it. Not the CCNPs, not all the networking gurus at the company. They were relying on the software was programmed correctly, and it was giving out the wrong IP to customers. And one of my students that had graduated and started working there saw it and figured out that it was giving the wrong address because he remembered addressing. And the other guys just didn't even think of it because they've been using this automated system. Well, they updated it, and it started giving out network IDs as usable IP addresses. So, and this is an automated system that's programming customers' equipment. Well, it's assigning them IPs that are unusable. Okay? So it pays to know that stuff, right? The software is doing it, but you still need to know addressing. I have tools to do everything, to make everything easier, to make everything faster, right? But I need to know enough when that tool doesn't help or that tool gets broken, right? Automation is one of the things we're going to run into, one of the things we're running into now is things are getting so complicated that the people working on them don't really understand how they work. They know that one little aspect of their job and they can do a repetitive task over and over, but they have no idea what they're actually doing. They're just following a set of steps. Anybody can kind of follow a set of steps. We don't do that. That's not our job in administration. That's not what we do in IT. We don't just follow steps. That's if what you call some dude in India to do tech support. They just read off a paper and follow steps. That's not what any of us do for a living. That's not our job. Okay? We have to know what the impact of the things we do. Everything else can be looked up. Like if I don't know a particular protocol, if I don't know what a particular acronym, look it up. If I look at an output, I don't understand what the output means, look it up. Okay? You're going to forget stuff. If you're not looking at outputs all the time, you forget what half the crap means if you don't work with it all the time. You talk to a person who only does routing. Ask them, that works for an ISP. Ask them stuff about spanning tree and see how well they do. This guy could be working in the industry for 10 years. He's forgotten what spanning tree does. He doesn't work with it, right? I talk to people all the time that have trouble remembering how to do the basic setup on a switch and router. They haven't done it in 10 years. They don't deal with initial configuration. They deal with huge advanced equipment and 40 pages of config, not this is the host name. They've forgotten the basic commands and only really remember the advanced commands that they use. Okay. Yeah. Flooding. So here's what happens. We flood a bunch of MAC addresses into the switch and push out all the legitimate MAC addresses and cause the switch to behave like a hub. What we do to protect against this is we do what's called port security. And we basically set it on the switch to say only allow these MAC addresses in. Okay? So if someone starts flooding the port goes in, gets turned off, and they can't flood our switch and do a MAC flood. Okay, that's the way we protect it. One of the first things we teach when you do CCNA, one of the first switching things we do in the second course is show you how to do port security to protect against a MAC flood attack. Okay, so no, because the purpose of MAC flooding specifically is to push out MAC addresses, so you need to rotate your MAC constantly. You basically, I can have 8,000 or 16,000 or 32,000 MAC addresses in the MAC address table before it runs out of memory. And if the oldest MAC addresses get dropped as new ones come in when it fills up. So if I fill it up with illegitimate MAC addresses that don't actually exist in my infrastructure, then when legitimate traffic comes in, it sends it out all ports except for the port it came in on the same VLAN. So let's add that component to that statement. So VLAN 2, it would flood it out all ports that are in VLAN 2. Same for broadcasts. So a VLAN is a broadcast domain. If I flood in a VLAN, it's only going to go in the VLAN. It's not going to go to the other ones. Okay? It's that separation. So we can do just floods. We can do just flood traffic, right? But what we're talking about is MAC address floods. We're using Nesys, is a program that is a traffic generator. Okay? So Nesys, and the other one that we use is maybe Nesys was the Cracker. I can't remember. I don't know. We use so many different tools. Okay, we use a traffic generator that will just make packets that have different frames, or different frames with different MAC addresses, and it will spit out 10,000 a second and instantly overwhelm the switch and continually overwhelm it. Because if we stop the attack, then the switch stops flooding. So we want to force the switch to behave like a hub and send out all traffic to all ports except for the port it came in on within the same VLAN. That means I can see traffic not destined for me. Okay? We often defeat this right off the bat with port security by limiting the number of MAC addresses that can be seen on an access interface. There should only be the MAC address of the PC, maybe a phone. So sometimes we connect the phone and then the phone connects to the PC. So there may be 2 or 3 MAC addresses. So I can go on the interface and say, learn the first 3 MAC addresses you see. Save those. Block anything else. Shut the port off if you see more than those 3 MACs. Or filter all the traffic except for the approved MACs that are there. Okay? So that's how we defeat that kind of. So what we're talking about, we also have different kinds of filtering. So the thing is we can filter BPDUs. So what happens if I see a BPDU on an access port? That indicates there's a switch plugged into the access port. If I see a BPDU, BPDUs don't come from computers, they come from switches. So if I see one on a port that shouldn't have one, that port may change its behavior. So for instance, I have port fast, so the port comes up instantly, but it sees BPDUs, it's going to turn off port fast because it knows a switch is attached, not a PC. Okay? Well, we can filter BPDUs. If we filter them, we block them, meaning we've turned off spanning tree. We've disabled spanning tree. BPDUs is how spanning tree works. So if we filter or block those spanning tree BPDUs, then we have essentially disabled spanning tree communication on the switch. Okay? So disabling spanning tree, we can use BPD guard, disables spanning tree on a port, and then BPD filter drops all spanning tree traffic. Okay? So power over Ethernet. Power over Ethernet is just what it sounds like. There are many versions of PoE. The original PoE was about 11 watts. Now we're pushing something like 48 or 60 watts. We're about at the limit of what Cat cable will take power-wise, though. The last thing we ever want to do is heat up a network cable. Network cables have very, very small gauge wires, very small. And so it can't take a lot of power. But this is how we power access points and how we power IP cameras. Okay? Access points being the most common. Excuse me. And phones. So PoE switch costs a lot more money, has a huge power supply in it, sends power down the port. We have a protocol that basically, and here we have AF is 13 watts, not 11, 25. We have a new version beyond PoE Plus. Okay? I don't think it's called PoE++, I forget what it is, but it's more than 25 watts. And the reason for that is the latest, greatest access points need a lot of power because they have many radios in them, and 25 watts isn't enough. So, but for phones, 13 watts is plenty to power a VoIP phone. And so you have a PoE access switch, and it maybe has a 700 watt power supply. That 700 watt power supply determines how many ports and how much wattage we can use on each port. And then there's a diode in the device that communicates with the switch. So initially the switch sends just an inkling of power down, just enough to turn up the port so the port can request how much power it actually needs. And then the switch then supplies that power so the device boots up and runs. This saves us cabling. It saves us a lot of hassle. Now I need one network interface, one switch port, and I can power a phone and hook that to a computer so I have less cables to put in. I'm also not using power plugs. I don't have power plugs all over the place. No, because in the phone is a switch. Okay? So inside the phone is a 2-port switch. And it supports VLANs and stuff like that and communicates with the switch to know what the voice VLAN is. So your data traffic flows through the switch and is unmolested, and then or it flows through the phone and is unmolested by the phone. The phone generates traffic and tags its traffic with the voice VLAN that's communicated by the switch. That's how we keep the voice and data separate, because voice has to be treated special on a network. It requires prioritization when there's congestion and stuff like that. Yeah, not always. We can prioritize traffic in different ways. It's one method of separating voice and data is by separating by VLANs. There are other ways for us to prioritize and separate and mark that traffic as well. But that's a very common way that we do it, is voice and data VLANs. Okay? So PoE switches are typically more expensive. However, I just bought a new switch, and then I find out the company is going to deploy voice over IP. Well, I can buy a powered patch panel. Okay? So the switch, all the cables go into the patch panel, and the patch panel has power injectors built into it that put voltage on the line for me. I can have a power injector. A power injector is a brick about this big. One cable goes in, one cable goes out. That's what actually comes with the phones initially, is you can get a power injector or just a normal AC cable, right? But the power injectors are huge, and they click together in bricks, okay? So let's say I have 4 power over Ethernet phones. Well, dude, I'm not buying a powered patch panel. I mean, dude, that's like $1,000 for that powered patch panel. I'm not doing that. It's way cheaper than a new switch, but it's still not cheap. So I'm just going to buy the $50 click bricks, and I'll have on one of my racks, I'm just going to kind of set this crap up here with the cables coming out of it. I'm going to have a big brick of 4 or 5. You know, that's fine. That's fine for small, but once I get more than 4 or 5 phones, I mean, where are you going to store and they heat up. They're a bunch of power supplies stuck together. It's absolutely, they're horrific, right? But, you know, it's, again, scale, right? We have small business. We have a little bit bigger, and we have equipment that fits in every one of those, and it's within different prices. So as we get it up into the big boys, the prices go up, okay? Hundreds of thousands of dollars for the equipment they're purchasing, up to millions of dollars for the big Fortune 500 companies that have 50,000, 100,000, 200,000 employees worldwide. To manage and to deal with that much data and that many people requires state-of-the-art equipment at very high prices. Jim Bob's Repair Shop uses Netgear that they buy on Newegg. And it works fine. And it's cheap. Netgear is great. Just don't put it under heavy load. Netgear becomes unstable quick. Okay? I have taken 2 ports on a gig switch and I blew it, and my switch locked up on me. Okay? With a Netgear. I had a 24 port. God knows what I'd do if I actually put it under heavy load on all 24 ports. Probably smoke. But I paid $220 for it. You get what you pay for. Okay? I didn't spend $1,000 on a switch. I spent $220. I got a $220 switch. And it performs like a $220 switch. No, it basically just crashes, and I have to power cycle the switch when it gets overloaded. When I try and push too much traffic to it, it just freaks out. I don't use it anymore. So I have a very simple home setup. I have a cable modem, and I have a home router. That's it. Now, it's a purchased cable modem that I own that supports over gigabit. So it does DOCSIS 3.1, and it's a $300 8 antenna Wi-Fi home wireless router that does all kinds of absolutely crazy crap. But it's basically just consumer gear. I'm just running high-end consumer gear. Nope. I have 150 meg down on cable 1. I have 150 meg down and 5 meg up. That's it. And I use about 400 or 500 gigs a month. And I live alone. I don't know. I haven't had, to give you an idea, I haven't had TV in a decade. I haven't had cable TV. I've cut the cord way before most. Like, I've had cable internet for, I don't know, 15 years or something like since it came out, basically. You know. And it was crap. Oh my God, it was crap. For years and years. The first year that I had it was 6 months of downtime. So on an average day, it was down 12 hours. So weeks would go by where no internet access, and I'd be using my dial-up again. It's rough, man. The moment you touch broadband and start browsing around, 10 minutes later, you'll never want to go to dial-up again. And it'd be down all the time. That was before it was Comcast, before it was AT&T. It was Excite at Home. And they went bankrupt. And they sold all the customers to AT&T. So the service just shut off. And 2 days later, I was an AT&T customer. And then they sold it to Comcrap. And now we have Comcrap on the West. Yay. Oh, hey, that's all we got for that. Sweet. So let's see, anything else? 13 watts, 25 watts. There's a new one. I don't know what it is. I don't recall. And then supplying device with a switch, power sourcing. PoE switch is an end span power injectors, right? So we have the PoE switches. That's at the end of the chain, okay? A power injector is actually going to come after the switch if we have a non-PoE switch, okay? And then we also have, I don't know what the phantom power mode A, mode B, I don't remember what that stuff is. I don't know. Whatever it says in the book for it. I don't have anything to add to it. I don't remember what those are. So you may get one question on PoE on the certification exam. I think there's maybe 1 or 2 in the entire test bank for PoE. Okay. So they really don't do much. Do we use it? Yes. Do you have to configure it? No. There's no configuration with PoE. You just plug it in. It works. Now there's some commands to see what PoE is doing, right? But there's no commands actually we don't have to configure or do anything. It just works, right? Let me see, what is... PoE Plus, this is March 2005, so there's a new one, though, after PoE Plus that does more. So there's so many standards. Things change all the time. Okay. Here we go. PoE Max. So PoE Max power pushes to 60 watts. That was in 2014. Okay. I knew we were close to 60. But not all, again, when you buy a PoE switch, it's going to have a certain flavor of PoE on it. Newer switches will be PoE Plus, and how many ports you can have PoE is determined by the power supply. So you may get a switch that can only run 10 ports of PoE because you only have a 350 watt power supply in it. Or you buy the more expensive switch that comes with a 700 watt or a 1200 watt if you have more than 24 ports. Okay, that's money. Okay, a $2,000 switch PoE, $2,500, $2,800. Okay. So you're going to add 40% to the cost on a PoE switch. Also, PoE switches will more likely fail The number one thing that fails in almost any networking equipment is the power supply. The more load we put on the power supply, the higher chance it's going to fail. Okay? Routers and switches don't fail. Their power supplies, their cards do. To have a board failure on a switch or a router is pretty rare today. A switch or router can run basically without rebooting for a decade without a problem. Okay? That's why they don't have very much RAM. That's why the operating systems are very small. There's no bloat there. It's not Windows. It's not user-friendly either. Right? This is not meant for real people. This is meant for people who have training on how to work with this stuff. Okay? What are we on for the end of Module 5? Oh, yeah. Well, I'm sorry. We'll be at the end of Module 4. So we'll finish that today. Because we'll easily be able to get through this one today. It's only 11 slides. And I won't go as slow. All right. Infrastructure and design. Architects. Okay. We have the highest that you can achieve in Microsoft and Cisco is a master level in Microsoft or an architect in Cisco. Okay. You know how to build 40,000 person networks. You know how to design. You're way beyond copy, run, start, host name, right? We're really advanced stuff. We're talking, you've been 10 years in the industry, you've been studying the whole time, okay? Design is one of the hardest things. One of the most difficult things in networking is to design it correctly from the get-go. And to continue that design as the company grows and as other constraints become involved. I may have to abandon my design in different ways because of company structure. I have to have a design that's going to be able to be altered and change with the company. Also, I have monetary constraints about my designs. What kind of equipment? I have to design things in ways that I have the funds to actually implement. Okay? If I have a company that's really well funded for their IT, I can do a lot more and I can make particular design choices versus a company where I have to do things is basically very close to our needs with not a lot of growth because we do not have a lot of money, right? A lot of resources. The larger the company typically means the better IT resources, the better software, the better hardware we're able to utilize. Okay, the more things we can do with less people because we have hardware and we have software intelligence replacing the people, okay? Which is important. Otherwise, IT becomes just a huge money sink if we don't do that. It requires too many people to manage a large network. So when we're talking about design, some of the very basic concepts of design is what are the different sizes of networks? What are the different types of networks? Each network has its own needs and its own design. WANs operate and are designed completely differently than a LAN is. A MAN is completely different than a LAN or a WAN. It's kind of in the middle. So first we have local area networks. We have your typical home network. We have SOHO, small office, home office. Okay, these are people who work from home, small offices, 3 to 5, 10 people. A SOHO network basically caps out at 10. Okay, so 10 hosts is what we would consider a SOHO. Once we get above that, we get to small enterprise. Small enterprise is usually up to a couple hundred hosts, okay? A couple hundred devices, usually 200 to 300. And then after that, we go medium. Medium goes up to 1,000. 1,000 and bigger is large enterprise, okay? Gives you some numbers. When I'm talking about small, we're talking between 10 and maybe 200 devices in the network. Okay, so this is a small business network. Okay, medium business would be 200 or more devices to 1,000. Large would be 1,000 or more. Okay, there are networks out there that have tens of thousands. There are networks that one physical location has 150,000 devices. That would be a Google data center. Their data centers typically house between 80 and 120,000 servers. plus all the networking equipment and everything else. Azure, Amazon, okay? Amazon's data centers easily have 50,000, 60,000 servers in them. We think right now, the last number I saw for Google is, because they don't release this information, we figure they have something around 2 million or more servers worldwide. A lot of hardware to manage. A lot of hardware to manage. That's why they have, they're a big employer. A lot of good jobs at Google. Okay, so enterprise LAN. Okay, so SME, small and medium-sized enterprise. Okay, we're talking less than 1,000 devices, basically. And then enterprise LAN is where we're getting into larger stuff. We have a campus area network. I have never seen it. I've never seen anyone use the acronym CAN for a campus network. One, we oftentimes in the industry do not call it campus area network. We call it a campus network. Campus network is like a college with multiple buildings. Okay? A LAN, a non-campus LAN, is typically one physical building that we're talking about. A campus LAN would be a LAN that spawns multiple buildings, a campus. Okay? So, Microsoft headquarters, campus LAN. Really, really big campus LAN. Aberdeen, or is it Aberdeen? I think that's it. Where they're, or Redmond, excuse me, Redmond. He lives in Aberdeen. Redmond is next to it. Bill Gates lives in, I've actually seen one of his houses. You can see it on Google Maps. It's amazing. It's on a really, yeah, it's on Lake Washington. It's pretty awesome. In Redmond, if you look at the place, it's actually like 90 buildings over a huge, massive area of where the Microsoft, that's a campus LAN. It's an extremely large campus LAN. But a college is campus. Clark College is on a hill and has a bunch of buildings. The whole LAN is all interconnected with fiber between the buildings. That is a campus LAN. Okay? They use a WAN to get out. But it's all LAN technology in there. And so we have wireless LANs. Everybody uses those, right? And then wide area networks. The internet. The internet's the biggest WAN. Okay? How we connect two local area networks together, especially when they're controlled by different entities, is a WAN. Okay? WANs are completely different than LANs. The companies that deal with WAN tech are different than the companies that deal with LAN tech. When I hire someone to work on WAN, I'm hiring an ISP, a telecommunications company, a managed services company, like Earthlink Business Services, okay? They manage WAN connectivity. When I hire for a LAN, I'm hiring a company like Taos or FlexTex, or I'm hiring internal people to do that work, okay? As a business, if I'm not a WAN provider, if I'm not a telecom company, I don't have hardly anybody who knows anything about WAN in my company. I only need to know how to get my LAN connected to the WAN. That's it. And so, like in CCNA, we don't teach anything really about the WAN except for how to connect to it, how to get yourself connected to the internet. Because beyond that, that's the carrier realm. And there's a whole different education train you have to take for carrier. Okay? So like if we're talking about the differences in like education and training for the different routes you could specialize in, CCNA is routing and switching. CCNA RS is routing and switching. That's a good path to go if you want to, and that's all about making routers and switches work on LANs. Then we have CCDA or CCDP, design professional. It's all about design, all about picking the right equipment and building everything in a certain way. So you learn about all the models of Cisco equipment and what models are used for certain implementations. So you can assist a company in designing their network and choosing the proper equipment, but you don't know how to set any of the equipment up. Okay? That is someone who does routing and switching. And so they diversify. We have wireless, design, voice, okay, or collaboration, it's voice and video. We have security. We have carrier, okay, so service provider is what we call it. And then we also have data center. These are all of the main trains of education you can achieve in networking. And so eventually you're going to specialize in one of those if you want to make really good money. Okay? We're generic right now. We're just kind of teaching the basics, right? So just because you work in networking doesn't mean you know anything about WAN. Just because you work in ISP doesn't mean you know anything about switching or servers. Everybody tell you know, well, do you know how to program? Oh, I know IT. You know, I know. So people contact me. Well, do you know any programming? No. IT is not programming. That's software development. That's not even the same. Information technology is networking, computers, systems. Okay. Programming isn't that. That's software dev. That's a totally different. You got to get a master's. You need math. There's all kinds of crazy crap. That's completely different than what we do. Oh, well, do you know how to make how to make a CPU? No. No, that's computer engineering again. That's comp sci. That's hardware design comp sci. No. Right? I get asked that stuff all the time. Like, well, you know computers. Do you know how to do this? Well, no. Well, why don't you? I thought you knew computers. That's not computers, man. There are 50 different categories of this stuff. We're teaching in like 3. It takes 20 years to learn all this stuff, man. You're not going to learn it very quick. You can't, there's just too much. It is overwhelming, and I understand that there's a lot of, some of the people in this course are frustrated because it's hard to keep up with. This isn't for everyone, right? I had a student come to me, and he was having a lot of frustration problems, and he was getting incredibly frustrated solving simple problems in networking. And we had a discussion, and it basically he came to the decision, based on my input and other things, that this was the wrong choice for him, that he would not be able to handle the frustration level in the industry. If you get frustrated just doing a little bit of stuff here, that's okay, right? It's overwhelming. But if you're getting so frustrated and so discouraged, you may want to go, talk to Barb. See, is this really the right path for you? Okay? Because it is not for everybody. Frustration is one of the things that we have to deal with as administrators. And it's way worse in the industry than it is learning this stuff, okay? It's hard to learn it, but it's way harder when something breaks and money is on the line and you have your bosses yelling at you and you can't make it work. Yet you're doing everything you know. You want to experience frustration, that's when you have people on the line and they're like, I'm losing $100,000 a minute. And because you missed something, it took 2 hours to get something fixed that you should have fixed in 5 minutes. And then you're kicking yourself over and over again because you made a mistake and cost people money and stuff. It's very, very, one of the reasons why I don't do IT today is the stress. You have to be able to handle frustration. You have to be able to handle high amounts of stress because that's what this money is on the line. This isn't video games. This isn't home networking. This is some of the stuff we do can endanger people's lives. We had an admin, to one of the stories that kind of goes with this, we had an admin screw up a server that has the radiation treatment for cancer patients on it. Okay? So that the device that's used, it's a radiation knife that's used to basically irradiate tumors. And they have a whole mapping program that's done for a patient. And my dad had to go through this, unfortunately. He passed away a couple years with cancer. So I know quite a bit about the stuff but I actually talked to an admin that this happened to, and it took him years to get over it. And basically what happened is he screwed up, and the computer that had that stuff on it wasn't accessible for a week and a half until they got it fixed. And that machine had the routine for the patients of what that device was supposed to do. So he put their lives at risk. What about if you work as an admin for a 911 system? Or you work in manufacturing and you are the admin that deals with the robotics, with the controls of that. A robot goes nuts, it can kill someone. It happens all the time. We have industrial accidents all the time. It's worse now that we've computerized stuff. My dad got his hand crushed making plywood. That was before it's all automated. That was just because someone wasn't paying attention. Hit the button and his hand was in there and it squished it flat. Right? It's worse now because we've automated something. There's not even a human involved. And so when the automation screws up, when this stuff goes bad, it can put people online. What we do puts us under a lot of pressure. And so that's something early on that I like to talk about. I didn't want to go back. I had enough of CEOs and people screaming and yelling at me for stuff that I had nothing to do with. I got tired of dealing with people. I hate people in general now. Like if you work retail for a couple years, you'll have a very pessimistic view of humans. A small percentage are good, and most of them are crap. That's kind of sorry. You do tech support for long enough, you can't help. But if you deal with people long enough, it's hard to be positive. And so one of the reasons I got the opportunity to teach, and I kind of fell into teaching. That was really not what I had envisioned to do, and I like doing it, and I get a flexible schedule, and the stress is way, way less than working 12-hour shifts and having people yell at me, why haven't you replied? We still have stuff down. Well, dude, we have someone in a car. He's driving there. Just hold on. He's 2 hours away. We had to fly him out there. Just hold your horses. Yeah, that's great, but I cannot make his car go faster. I don't know what you want me to do. Right? Well, you need to fix it. Yeah, that's great, but I can't. I'm not a wizard. That's not how it works. And people think that you can do that kind of stuff. You know how many times I've talked to people and they're like, you can see what I'm doing, right? No. Why? I just had someone ask me this a couple days ago, one of my students. You can see what I'm doing, right? No. Why would you just think I can see what your screen? I'm in a different state. You're in Washington. I'm in Idaho. How the hell did I just magically see your screen? I had people in 96, 97 ask me that. No, I'm actually sitting there with my eyes closed and I'm doing it from memory. I can't see your screen. I have tons and tons of fantastic stories. Okay, back to this stuff. Sorry. MANs. Oh, no. Intranets. Internet, big internet, right? And then we have intranet. And intranet is our private network. Okay, that's our business network. It's called the intranet. We create security zones and we have different things like internet is considered not secure, but intranet is a secured area of our network. And then the extranet is an area of our network between the internet and our LAN that allows vendors that we work with. So let's say I'm a manufacturing company and I have vendors that have to get prices and stuff and do orders through my website. But that website is not available out on the internet, okay? It's only available to vendors that have accounts with me and stuff like that. That would be an extranet, okay? So it's strictly used, it's an area of our network that is kind of segmented out and protected, but is not necessarily directly open to the internet. They have to use VPN or some kind of access to get into the extranet to give them access to some of our resources, like our price lists, our availability of different, I'm an auto parts manufacturer. So they need to order 2,000 manifolds, and they need to see how long that's going to take, what the prices are going to be, that kind of stuff. I'm going to have that all available, but do I want to advertise that to everybody publicly? No. I want it to only go to the people I'm working with. Okay, so that's an extranet. Yeah. Yep. Yeah. We've got it firewall. It just depends on the kind of extranet you're running and the people you're working with. Sometimes we're actually doing like leased lines to these companies because we work with them very, very closely. And so we have dedicated connections to these companies. Sometimes we're doing VPN technology over the internet, and sometimes it's just a protected website. Okay? Just depends on who we're dealing with and what kind of business. It kind of goes through the gamut based on what those needs are. How high security is it? Okay, I'm a defense contractor. It's not a web page. Okay, it's not a web page. It is a dedicated link, okay, that doesn't go out to the internet because I'd like to keep my contract. Right? Everybody is required to have background checks. Everybody has to have security clearance. I have to have ridiculous controls on my network and everything. Ask Boeing how well this goes for them. Right? Boeing has been busted a bunch of times and surprised that they still get to make military planes at this point. They sent some instructions on one of the engines to China or Russia or something like that last year. It's just amazing the mistakes they make. It's only because they're that big that they still get used with making those mistakes. If you're a smaller defense contractor, they don't let you make those mistakes and keep your contract. Boeing's so damn huge, who else are you going to go to? Airbus? Wait a minute, they're not a U.S. company. Lockheed Martin, well, so we have very few choices to go with it, and military want it built in the States, man. I don't want China building our planes. I think we're going to have some problems with that. Have you heard about Kaspersky? Yeah. Yeah, they just posted that they did steal hacking tools from a CIA computer with their software. They just admitted to it today, and it was posted. So a Russian company that had been doing business in the United States for many, many years, then turned their software to spy, and now everyone in the United States is trying to uninstall the crap and get rid of their software because it was basically hijacked by the Russian government to spy on us, and they've been stealing all our stuff. So, man, I'm a man. Metro area network, big loop around a metropolitan area, much faster than a WAN, much cheaper, but not a LAN, right? So it's different kinds of technology that we're using there. Usually we're using the protocol called MPLS, multi-protocol label switching something like that. Multi-protocol label switching something protocol. And so we have infrared. Yeah, we have it. I don't use it anymore, but we have it. I haven't seen anybody use infrared. What do we use infrared now for? A remote. That's about it. Okay. We don't usually use infrared too much. Bluetooth, no longer widely supported. Yeah, let's make that really clear. Infrared doesn't come on computers and stuff anymore. Used to. Now it's all Bluetooth. Bluetooth. 3 megabit over 10 meters, basically 30 feet. It goes faster than that. We now have like 24 megabit or something like that. We call it a PAN, a personal area network. What do we use Bluetooth for? Syncing to your car and syncing to your headset. Oh, and mice, keyboards. We use Bluetooth mice and keyboards. Okay. NFC. Okay, turn it off. First thing you do when you get a phone, turn NFC off. NFC, near field communication, allows you to get a phone close to another phone and transfer data. So when you're on the bus, you're in a crowded area, I'm hacking this phone, just walk away, because all the Android phones have NFC enabled. So at a distance of about this far, NFC is available, I think, on Android for the latest, or on iPhone for the latest ones. I'm not 100% sure on that. But yeah, 2 inches, works up to 2 inches, a little bit farther than that. But it's great, it's convenient. Hey, I want to transfer you a photo. Bing. Yeah, turn that off. Security. Yeah, exactly. I want to steal everything that's on your phone. Bing. So we want to, typically with anything that we're not using that we really need to use should be disabled. Consumers can have all that great stuff turned on. In business, we can't. People actually want our stuff. Nobody cares about you as a home user, okay? You don't have anything of worth. Are you a millionaire? Are you a multimillionaire? I don't care. They're like, I don't care about you. I'm a hacker. Your information, your credit card information is worth $1 to me. Your social security number is 50 cents to $1.50. Okay? That's what it sells on the black market for. You're worthless to me as a hacker. So how do we get hit? We get stuck in botnets, malware, that kind of stuff. But no one's going to target you directly unless you're pissing off people that are hackers. Well, I have done that. Don't do that. Okay? So long as they don't know who you are, they don't care. Businesses have stuff worth money. This is no longer a game. It's no longer script kiddies. It's no longer kids learning. These are Russians. These are people all over the world, governments that are making big money. There's corporate espionage is alive and well today. And a lot of it is social engineering and hacking that's happening. Okay? So NFC, turn it off. If you're not using Bluetooth, don't have it enabled. All these things, there are all kinds of hacks for this stuff. Wi-Fi protected setup. Great thing at home, right? You hit the button, you can easily sync up your printer, turn that off. WPS is broken. Anybody can get secure access to your network now. Yeah, great. You don't have to hit the button. There's a known hack for WPS, came out 2 years ago. First thing you do on a home router, turn off WPS, turn off UPnP. Turn off all these features that make your home network immediately hackable. UPnP is probably one of the worst things out there. UPnP, Universal Plug and Play, okay? It lets your printer open up a hole in your firewall so the printer can be directly accessed from the internet so you can have that wondrous email printing, right, with your new HP. So any device that needs access to the internet, UPnP gives it the ability to open holes in your firewall on your wireless router or on your home router. Okay, so the very first thing you should do on a home router, which I'm sure all of you will be going home going, oh, is that turned off? It's probably what's going to happen. Turn off UPnP because it just opens holes in your firewall. Why would you want that? I want to know what's in my house and what's communicating. Most average people don't care. I do this for a living, so I care because I actually know. I actually know what could go wrong, right? So it'll work. It won't screw with your wireless at all. But if you have one of those, so I have an OfficeJet, an all-in-one OfficeJet, a relatively new one. It's about 3 years old, I guess. It supports all the web printing and like printing from your phone and all kind. That uses UPnP. Okay. If it's just wireless, that's fine. Okay, so long as you're using WPA2 and you have a secure wireless network, it's secure. You're fine. But it will go open holes in your firewall with UPnP, and it's always turned on by default. Okay? You're going to learn all kinds of stuff like that in this course. But every other night, you'll be going home, oh, this is set this way. Oh, gotta fix that. He said this is bad. So, well, yeah, when we get to wireless, we'll talk about one of the worst things that everybody uses. It's called captive portal. Okay, the number one thing that botnets are being created with are printers, DVRs, all the devices that are in your home that are opening holes with UPnP. They don't want your data, they want your bandwidth. Okay? They don't care about you. They don't care about your information. You're not worth anything. Your devices can be used in denial of service attacks. And so that's the problem we're having right now, is that there are DVRs and there are routers and there are stuff out there, all this consumer gear that is hacked and is being made part of the botnets. Smart TVs. Well, some of the Samsung TV, they record your voice, right? Well, if you hack the smart TV, I can record everything in the room anytime I want to and have it streamed to me. Okay? These are the things that we're concerned about. Think of a TV in a boardroom. Smart TV in a boardroom. God, wouldn't that be nice? Do a little insider trading. I could turn something, if I knew what I was doing, and I went to the right company, doing something like that could make me millions of dollars. I could easily do insider trading based on, I'm listening to the damn board meeting because I've hacked their TV and I've turned on the microphone for their smart TV. Okay? Those are the things that it's not your social security number, it's not your credit cards yourself, because I can hack the bank and get all that information. So hacking your computer doesn't get me anything, but I can use your computer and your device's horsepower to do DOS attacks and botnets. So when we talk about there's 200, 300,000 hosts in a botnet, those aren't necessarily computers, those are home routers that have been compromised. Those are home devices that have been compromised, and a great deal of them, part of the reason they got compromised was UPnP. UPnP makes them accessible from the internet, from the outside. Okay? Yeah, it's usually the botnet stuff. Botnet is mainly just DOS attacks, DDoS attacks, right? The biggest DOS attack in the world was done last year against Spamhaus. They're a big anti-spam company. And it slowed down most of the East Coast for about 6 hours, 6 to 8 hours, and it was called an NTP reflection attack. The two largest DDoS attacks we had in the United States happened in the last 2 years. The first one was a DNS reflection. The next one was NTP, Network Time Protocol. They used a bunch of the Network Time Protocol servers to reflect and enhance the attack. And so they used just basically a bug, a security issue in the servers, and used the servers to do the attack. And used other people's DNS servers. We don't, like when I launch an attack, when I do a DOS attack against someone, I'm not using my own stuff. I log into a control server and tell it to tell all my bots to then send pings or send whatever kind of traffic I want. And then I use everybody else's connection. That's how you can overwhelm even the largest organizations. They can't we have botnets that have 1 million devices in existence. They're run by criminal organizations. You can go on Tor right now. I can go on Tor and I can pay for Bitcoin if I want a site down. I put in the site's address, I put in how much Bitcoin I want to pay for it, and they'll tell me how long they're going to keep the site down for me based on its size. Anybody can do that if they know what they're doing. It takes 10 seconds to show you how to use Tor and find the websites where you can hire botnets that run all over the world to attack your, let's say I run an e-commerce website. We're getting to Cyber Monday. Woohoo. I'm a specialty website. I only have a couple direct competitors. Cyber Monday, all their sites are down. Mine is super fast. I wonder what happened. Cost me $1,000 to take out my competition, and I just bought some Bitcoin and hired someone completely anonymously to run a 200,000 device botnet against their web servers to take it down for 12 hours on Cyber Monday. So everybody will go, oh, well, I can't get my order in, so we'll just go to the competitor. Can't do that to Amazon. Good luck. Good luck. So the biggest of the big have the ability to defend against this stuff, but everybody else can't. They don't have the resources. It's just there's not enough horsepower. So, list of requirements. Why do we build a network? What is the purpose of it? At home, it's for gaming, connectivity, watching TV, right? Business, we have business reasons. We have everything we do in a business in IT is based on what the business needs, not because I saw some nice shiny gear. That happens, and those admins sink the companies that they're involved with. They treat the company as their own little play area. Oh, let's get this. Let's get this. I've worked with people that are like this. Clark College is kind of like that. That's how they got a Cisco ASA. They bought an $8,000 Cisco ASA, sat on someone's desk for 2 years before they put it into use. Now they just replace it with a bunch of Alta. So this is state money. Taxes paid for that. Security appliance, adaptive security appliance, sorry. So Cisco ASA is a security appliance. So firewall, VPN, IPS, they range in price from $500 to $100,000. List of requirements, business goals and scope. Okay? Is this a global company? Is it a local company? That determines a lot. A lot of how we do our design. Are we going to have a massive headquarters? You know, where like Amazon is now taking proposals, 128 cities have now submitted proposals to become the second headquarters of Amazon. The second headquarters is easily going to employ 20,000 people. Okay? The first headquarters is like 40 or 50,000 people that's already there. Okay? Some of these facilities, like Redmond, there's 20, 30, 40,000, 100,000 employees in one small city. Intel has a place in New Mexico that at one time had its own McDonald's and its own 2-year university. 35,000 workers were there. Okay? It was Intel's largest manufacturing plant in the United States. I don't even know if they're there anymore. But it was basically a city. We have companies that employ that many people. Now, I wonder how many people work at the Gigafactory for Tesla. 5,000? 8,000? Maybe more? It's the largest battery, factory in the world. Okay, think about managing connectivity for 50,000 people in a small location. Imagine doing it with wireless. That should be fun. Okay. So business goals, scope, budget, timeframes, and deliverables. How much money do we have? What time? And what is going to be deliverable? The staff and stakeholders. Who is this going to affect? We're going to build a new private cloud. Okay. What departments are going to have services that run on the private cloud? Those are stakeholders. Anybody who has a stake in using this, the people that decide, the people who are going to run it. Okay, just because I implement something new doesn't mean my staff are going to be the ones implementing. If I need a private cloud, none of my staff have really done that stuff. I train the staff on how to use the private cloud, how to manage it, but not implementation. I hire an outside resource to do the implementation. We do that with wireless networks all the time. Large wireless networks require special hardware and software to be able to make. Okay, you need site survey tools. Those things are expensive. And it takes some knowledge to use them. Well, if you're not a wireless admin, you're not going to know how to do a lot of that stuff, so we'll hire an outside company to do the initial install and to train our staff on how to manage that part of the network. Okay. Security considerations, obviously. Environmental limitations. Can you get enough power? You want to build a data center. Well, can you put enough power? Is the data center's foundation in like a sandy area? Do you have a good enough foundation where you can support 5,000 or 8,000 pounds in a square foot? Because that's how much a rack weighs. Each server weighs 150 to 200 pounds sometimes, maybe more. 100-pound server, you can put 40 100-pound servers. 4,000 pounds in a spot that is basically yay big. Okay? Do you have a building that can actually handle that much weight? Do you have a floor system that can handle that much weight? All kinds of crazy considerations we have to have in place. What about environmental? There's a reason why we do not have many chip manufacturers in the United States anymore. It's because in other countries, the chemicals and stuff that they deal with in manufacturing of microchips are extremely deadly. They're very hazardous to the environment. The stuff that they do is just nasty stuff. And it's just simply too expensive to deal with the EPA and all the regulations and stuff of doing that kind of work here in the United States. So it's far cheaper to do that in other countries. Not just the cost of the people, it's the cost of everything involved is just simply cheaper. And that's why that industry has moved. That's why most of our chip manufacturing is in China, Malaysia, Taiwan. Okay, Malaysia being huge. That's Intel's main manufacturing location. Is Malaysia. Most of the i7s and stuff you have are going to be in Malaysia. Okay, we have Micron. They make chips here. We have WaferTech. They used to make NVIDIA processors here. They're a specialty. We have some. Intel still has probably one or two foundries. They're called foundries. Okay, but there are very few foundries in the United States when there used to be hundreds of foundries in the United States. And a lot of that has to do with environmental limitations, environmental issues that we incur. Okay, large networks use a lot of power, they generate a lot of heat, and there are concerns about having enough power, having enough bandwidth. If I'm building a big data center, the amount of research Facebook has to go into to figure out where they're going to put their next data center is immense, because it can slow down the whole internet in their area with how much bandwidth they can utilize. Yep. Don't build a data center in Arizona. They're all over Texas. Texas is huge high tech. So is Arizona. What? How are you going to cool it? How are you going to? Oh my God, that's it. California suffers blackouts, and you're going to run a data center there? Are you nuts? Hydropower, dude, get yourself on the Columbia River. Why? Hood River. Big Google data centers in Hood River. Why? Have you gone down the road near the gorge? There's nothing but horrifically giant power lines and huge windmills everywhere, hundreds of them, all down the gorge. Well, yeah, dude, Google went, put their data center right in the middle of all of it. Guaranteed power. And they're right on the Columbia. They're not far from the I-5 corridor. The I-5 corridor is one of the largest collections of fiber anywhere on the West Coast. We run the fiber right down the train and the road all the way from the top of the United States all the way to Southern California, right down the I-5 corridor. We have no flooding, except for last spring. That almost potentially could have flooded all of downtown, including the airport, which is where the big data center, one of the big data centers here is at the airport. That's, yeah, good times. That happened. We're not on a major fault line. We have a very good amount of bandwidth for our location, which is kind of surprising. We have a decent pool of people here. There's not, we don't have a lot of fires, we don't have earthquakes, we don't have a lot of tornadoes, any of the things, so that's why FiberPipe is building a tier 1 data center here. It's why FiberPipe runs HughesNet here. They're one of 16 terrestrial stations for satellite. And so if you go down to Emerald and you look at the back of FiberPipe's building, you will see the largest satellite dish you've probably ever seen face to face. And that is for tens of thousands of satellite customers that use HughesNet. That's how they get to the ground. So that's how their internet signal comes. They're shooting it to the satellite, and then they get it. They shoot theirs up the satellite. It comes down, and then they're using FiberPipe if you're in anywhere in wherever this satellite that they're off of. And I'm sure they're feeding a couple satellites from the setup, I would imagine. Because HughesNet has quite a few satellites up there. Okay. So compatibility requirements. If you buy all Cisco gear, maybe you want to use some Juniper proprietary stuff. Some of the proprietary stuff is totally worth going after. Okay, it is that much better sometimes. Okay, there are some things we'll talk about in Cisco where Cisco was proprietary and it took 10 years for everybody to catch up. Now everybody uses the open standard and it's based on Cisco stuff anyway. Okay, there's a lot of examples of that. Okay, so compatibility is a big deal. Juniper has a different form of spanning tree that they use that's not compatible with anybody else's. Okay, yet at one point they were compatible with PVST, so you could use Cisco switches in a Juniper environment. But Juniper switches support STP, but they also support their own flavor of loop reduction, whatever you want to call it, right? Loop removal. Okay, device types and requirements. What kind of devices we need? Firewalls, switches, routers. How many ports do they need to have? These are all the things that kind of come into planning, right? Into the design. So how do we select the correct technology? Well, we don't want a one-off, okay? We don't want a product that has a limited run. We don't want a product that just does really one thing. We don't want proprietary systems. I don't want to deploy my CCTV system and have it all be proprietary everything. I want an IP-based CCTV system so I can use all that my network has to offer, okay? I want to make sure when I buy devices that they're not wholly, that they can be flexible with the different vendors, okay? Some devices will only work with that vendor's gear. That's when we're dealing with proprietary technology, okay? How flexible, how scalable. Switches, fixed config, okay? Let's take a look at a couple switches here, okay? Oh, let's bring up, they have way too many notifications. This is horrific, okay? So let's take, what is a fixed configuration switch? So let's look at a Cisco 3650. Okay, these guys range about $4,000 to $15,000, but they have relatively limited capabilities. They're a switch. They're not very modular. Okay, what happens if I need to add more ports? I can't. Okay, what if I need to change the speed of the ports? I can't. The ports are fixed. These ports don't come out of this thing. I need to increase the memory. I can't. Okay? I can't increase the flash and RAM. This thing is not upgradable. It's not adaptable. But I may want to choose this based on what my needs are. I may not need adaptability where I'm using this switch. So this would be more like an access layer switch, right? The beauty that this switch does is it can control 25 access points. It has a built-in wireless LAN controller in it, okay? So I can pay the extra money and I don't have to buy a separate wireless LAN controller to control all my access points. I can do it via this, and I can get this in a PoE. So it not only controls the access points, it powers them too, provides all their network. That's what this switch is specifically designed for. So I get some capabilities and scalability in the areas that I would choose this switch for. I would choose it to power my wireless network and to control my wireless network. And because I can choose a switch like this, it's much more cost effective because it has the power, it has the network connectivity, and the wireless controller all in one box. Okay? But not very flexible, not very scalable. So what if we get into the bigger boys? So let's go to Cisco. Let's go to Cisco.com. We can go to any company, right? Let's go to Juniper. Let's take a look at Juniper's. I always use Cisco. I usually teach Cisco. Let's look at some of the other vendors. Okay. So, no. It's JuniperNet, not Juniper.com. It's like, yeah, that's not right. So Juniper is the number 2 in the switching and routing world. Number 2 or 3, they're pretty high up there. Okay, and so if we look at, we have all kinds of different stuff here, and so what we're going to look at is, let's look at switches. Okay, and so we have the run-of-the-mill EX switches. Okay, and these are, let's see, do they have any good pictures of their stuff? No, of course not. Let's see an EX220. So this is what it looks like. Nice fixed configuration, okay? Nothing real special. So this is a run-of-the-mill access switch. Nice, cheap. We have tons of them. We use a lot of these, right? But they don't do a whole lot. They're not super fast, okay? But then we can go into something like, an EX4300. Okay, so this is going to have a lot more. Well, it doesn't look much more. It's going to have, you've got optical fiber here. Okay, we may have stacking modules in the back where we can stack switches together and make them work as one, so we can get some scalability. That's kind of a cross between a fixed configuration switch and a modular switch. Fixed configs oftentimes aren't stackable. Then we have stackable switches. Then we have modular switches. That's stacking. Virtual chassis are stacking is the technology we're talking about. But if we get out of the EX series and we go to the QFX series, now we're going to be looking at some bigger boys. Okay? Okay? So this thing is going to support some pretty amazing levels of connectivity. This is probably all 10 gig or 40 gig interfaces. That's because it gets hot. Okay? And then we can step up even further. So let's go to their next line. These are strict fiber switches. Okay? To give you an idea, let's look at the speeds. 1.4 terabit per second performance on that device. Okay? This device is probably a couple $100,000. Okay? So Nexus 9000, Cisco Nexus 9000. Okay? This is what you run a data center off of. One of these boys is about 250 grand empty. Okay? Once you fully load them, they can be in excess of $1 million. Okay? At the bottom are the power supplies. These modules can be swapped out. All of these are optics. So this is all fiber optics. These are all 10 gig, 40 gig, and 100 gig interfaces. Okay, so these are what the companies like Google, Amazon, and stuff buy. And they have quite a few of them. So these are modular. These are hot swappable power supplies, hot swappable components, multiple brains, failover, all kinds of crazy technology. Okay, these cost a lot of money, and so These will be more of our high speed, more of our distribution layer switches that our computers don't directly connect to these, right? This guy would be servers and storage would be connected to here. This would be running a SAN. Okay, it's what we refer to as a fabric switch, is what we're talking SAN switches. The Nexus line of switches are fabric switches for data centers. And they start all the way at $1,000 and range all the way up to $750,000. Okay. Again, routers. Let's take a look at some routers to see kind of the differences. As we buy these things, as you pay more money, you get more flexibility, more uptime. Okay. So if we're looking at CRS3, this is Cisco's most powerful router. The Comcast runs this. These are the routers that run the internet. Okay. Here you go. There's a CRS3 cluster. Because they're showing them off. Okay. So this is CRS3. These are an empty box is 80,000. They usually run for a cabinet like this at about $1 million. So to give you an idea, some of these cards are $100,000 each. Okay, so just one card can run you $100,000 to $150,000. And some of these units will take 12 to 16 to 32 cards. Okay, and we can cluster them. So we can take 80 cabinets. The maximum throughput that this thing achieves is 400 terabit. And it takes something like 80 cabinets all linked together to hit that speed. So you can build the fastest routing cluster in the world if you have $30 or $40 million to route the entire internet all at once. You can run a whole country off of one of these, man. Not the U.S. maybe, but you can run some countries in Europe off of one of these things, right? These are the state of the art. These can be upgraded under load. You can just pull cards out while they're running. You can pull the brain out, replace it. It's got 3 of them. It's got just ridiculous redundancy. All kinds of failover. You just pull stuff out, and if everything's configured correctly, it won't even notice. It'll just swap the traffic to another port, take over, plug it back in, it'll switch back. Yeah, no, all this stuff is a hot swap. Okay? So where we get into design, there's a simple design that we use. Okay, data center is kind of separate from that, but we use this design, and honestly, it's based off of Cisco, okay, as so much is. Why? Cisco dominates the industry. That's why. They're the ones that set the rules. The ones that set the rules for half the protocols we use that are open source today were originally developed by Cisco 15 years ago. Okay. So we have the core, okay? The core is speed. That's all it is. The core, we aggregate in tiers. We have the access layer, okay? We have the distribution layer. And then we have the access. This is the access layer, okay? And it goes kind of like this. Over there. Okay, so PC is plugged into the access layer. The access layer aggregates to the distro layer. The access layer is where we do port security. It's where we do quality of service tagging for prioritization. So we have a lot of security in place here, but these don't do routing. These are layer 2 switches. Okay? They aggregate, so these may be 10-100 ports, 100 meg ports. These will be 1 gig. These are 1 gig, these would be 10 gig. This only connects to other switches. It doesn't connect to hosts. It's a distribution. That's where all the VLANs and the firewalls and stuff come into play. So all the VLAN routing is handled by distro. Okay, so these are the layer 3 switches. Okay, and so how this works is in a building, everything on a floor, all the access switches would aggregate to this, and then this would be maybe in another building or on a different floor, and this is how I get from one floor to another. Okay, so if I want to get to another set of distribution in a different area, I go through the core. If I want to get within a VLAN that's in this part of the network, it never leaves this area, it stays in distribution. Off of the core is where I put the data center. The core is just raw switching speed. So these are big, powerful, high-speed layer 3 switches. And these are the ones that we're going to have 40 gig interfaces, maybe 10 gig interfaces, and we're going to aggregate all our traffic. And so how we would do in like a building, let's say I've got my core, okay, so I've got a core here, and this is maybe in my main building, right? And then in a campus, okay, so I have, in this building, I also have distros, and I have access, okay, for that building. But I also have other buildings where I have distro connecting and then all the access switches. And so for me to get from this building to over here some other building, I go access to distro to core, back to distro, back to access. So that's how I get everywhere. The hub and spoke, aggregate everything up, spit it back out. The reason we do this is scalability. If I want to add more users, I can just throw another distro switch in here. Add a bunch of access switches to it, interconnect all of these together. If any one of them fails, I don't lose anything but bandwidth. Okay? Even when the core, we always buy everything in pairs of 2. Never buy one switch, you always buy 2. We install everything in pairs of 2. Okay? Redundancy. I don't buy one distro switch, I buy 2. I don't buy one core switch, I buy 2. And they're interconnected. So I can have one distro, one core, all of that fail, and all I lose is bandwidth. I don't lose connectivity. Money. Enterprise redundancy is expensive. You have to buy 2 of everything. The things that you buy also have to have redundant power supplies. How much money do you have? How important is the uptime? Well, I lose $1.5 million a minute. We do online trading. Okay? If I lose internet access, my company will lose horrific amounts of money. Okay? Then we do whatever it takes. Money is simply not a concern. We do whatever it takes to achieve the level of redundancy to achieve that uptime, because we're not a business if we don't have it. I run a kid's playground. We have a website. Don't care. Don't need any redundancy. It's down. Oh no, they'll have to call me. Right? So access, where all the hosts connect to access, we do a lot of security there, but there's really no routing. We trunk it up to the distros. That's where all the intra-VLAN routing happens. Anytime I need to get out of that section, it then gets switched up to the core. And these are all layer 3 switches, except for the access are layer 2s. Well, the access switches, how many access switches do I have there compared to distros and core? Core switches are expensive. Distro switches are expensive. Access switches, they're cheap. That's why we have the different classifications of gear. That's why I just buy a bunch of 48-port fixed configuration switches that don't do a hell of a lot. And I can spend $1,000 or $2,000 a switch when I'm spending $20,000 a switch on the distros and $50,000 a switch on the cores. Okay? Small company, call it collapsed core. We combine the core and the distro together. Okay, so all that functionality happens on the same equipment. Okay, so this is how we get scalability. If we build a flat design, everything just daisy chained together, guess what? That doesn't work. Works good for about 3 or 4 switches, daisy chain. And 5 is the limit. We actually have a distinctive limit. Spanning tree will start crapping out with a network diameter of 5. Okay? There's a lot of physics, a lot of thought, a lot of engineering involved in this. Just the way it works. Electrical signals only travel so fast. We can only have it go through so many switches. Okay? What do we got? Power over Ethernet. We don't really do it very much. It doesn't work very well. It's Ethernet over power. Power line Ethernet is what we call it. Okay? It's using the power in it doesn't work very well. Yeah. which is totally not designed for anything but power and not designed for networking at all. When you can't run cables, this is an option. I've never seen it used, nor would I ever recommend anyone use that technology. Okay. I don't know. I have no idea what the speeds and stuff are on this thing. Okay. So wired wireless considerations. This is planning a SOHO. This is one of the things that we could plan in a SOHO. Environment limitations, equipment limitations, compatibility, all those considerations are the same for a small network or they are for an enterprise network. Considerations and stuff don't change just because of the size of the network. Okay? Just so there's a lot more factors in a big network compared to a small one. But all these considerations are the same that we saw over here. Okay? Nothing really different there for SOHO. Just the classification equipment that we use is different. And the devices we have. And we have some things that we would do in a SOHO that we wouldn't touch in enterprise. Power line networking would be one of those. Okay. Let's see, what else we have? We just have a few. We'll finish those tomorrow. That's all we're going to do tonight. We'll finish that up and get into the next module tomorrow. And then remember, we are meeting Friday. Right? We're meeting Friday this week. Okay? And next week. Yeah. So we're next Tuesday, we're not meeting. I have to work anyway. I teach Tuesday night. It sucks too. That's my birthday. I was born on Halloween. Yeah. So I will be working till 8 o'clock at night when everybody is taking their kids out for trick-or-treating and everything. I will not be doing that.